Okay, we'll jump in here again for another round. Very simple little script, post and pre Python. Actually, not too much pre, just dealing with gene pools again as the data to build geometries. And you can see what I have here is a very simple script, still keeping in line with the Rhino script syntax is RS and the Rhino geometry is RG, just to keep Rhino common going as long as I can. You'll see that I'm generating point A and point B using those functions in Rhino geometry and Rhino script. It's not recommended you import both at the same time because you might end up confusing these RG and RSs. But you can see I'm doing two iterations dealing with an array of points, I in range X and J in range Y, which are being generated by a list. So you've got multiple points, which generate a whole bunch of wonderful lines. If we take a look in here, these lines and these line and this initial line, which is an axis. So even though I'm generating these start finish lines on the X and Y, I'm revolving those around an axis, but to keep that a little more exciting, I've taken the rotate geometry and played with it off of a pi factor of rolling that and building a geometry this way. Some of it defaults. At times it really works, and once again, you can just go into gene pool and optimize. Now, if I optimize too much, I really blast it. Once you get it to work, you probably don't want to randomize more than by 10%. And you can see that I've jumped into here, and I did a little bit of playing around with the I's and J's in here, which I'll leave it up to you to play with. If you remove those I's and J's, you'll go back to cone shapes. If you just bring that back to a 0 and this back to a 0, because you're really just bringing up in the Z direction I times J, and you end up with something kind of normal like that. But I'm quite interesting when you get into doing things like this. It ends up building much more complex and interesting geometries. I threw in a little brep, and some of those don't brep probably because they're too closed. So you might have to get that node to activate, you might have to go in here and just randomize by 10. Actually, I defaulted the whole thing. Let me jump into there. I think there we've got it working there. And it actually closed the brep on everything. And you're left with a single brep, which is kind of nice in a post node. So you can build a geometry that way and model in this kind of way and end up generating something that would be much more difficult to randomly kind of come about in just using CAD program. But these geometries might end up being sculptures. They might end up being something of point of interest to you. And then certain modifications. I really like using this tool just to alter it by 1%, alter it by 10%. You can see that there's little subtleties. Let me see if I can grab this final one and optimize by 10. You'll see those little subtleties happen in the base. At that point, you can also take your planes and rotate them and just swap those out. And you'll end up pulling it in the other direction. So that's a very simple little shift. Just to play off of that as well. So little fun things. And then if you want your rotation to go beyond 2.0, you can bring that up into a much higher count so you can see what happens. You still have a way of modeling and moving. And the sole point is to be a sculptor as a digital modeler and start to sense what you can do and optimize and choose what you want this program to run. And as long as, like I said, these closed breps happen, you might have to play around with it until it kind of goes into a close. But I obviously have a problem within here with some of my data to keep that red, so I may have to just play around and find out what it is. It might be one of these points here. There it is. That one was just not closing up. And once again, you've got another geometry there that you can simply throw into a bake. You don't have to unify things if you want to, but they're all coming in as a closed single brep. And you've got that one that you can pull up and play with that one later. And once it's in CAD, then you can do all your other funny stuff that you ever did before, which doesn't have to be the Python node. So another great example of just going through the back to the basics. I think this is 2.0. I'm calling this or 002, and it's dealing with array of points. I'm going to go on to conditional examples. But once we hit that Python node with a little bit of playfulness on the input side, we can then bring it out. Now keep in mind you're going to have to still keep these as a type int integer, and you can leave it as a list item, even though you're bringing in a single item. That's what it's called. Let me just see again. Bring it in as a item access, but because you're bringing in a list, it's just reading that. And you may have to play around with your grafting and flattening to make this work, but you'll become more and more proficient and hopefully use these scripts. I don't like what I did to that one. I liked it actually more in that mode. And then you can go back in and you can try something else with your codes as well. Let's do a major shift, randomize, and see what happens. Nothing's happening different on that one, or else, there we go. Got a nice little one there, and I think I'll just swap that back into the other position. And then I'll take a quick bake and have another geometry. So really, it's about sculpting, but becoming a digital sculptor, in my opinion, and digital modeling becoming a role in creative mold for artists to consider making shapes, tool paths for milling, creating molds, taking prints from things, and avoids kind of scanning and going in and finding your own STLs and OBJs online. You can just generate your own kind of 3DM files. Hope you enjoyed it. I'll keep going.